got a drink.
No.
Yeah.
I'm not a frat boy anymore.
You know, you could have, not me, but you should pick something from the audience.
Oh, yes, this will be a prize if anyone wants to answer some questions. God. That thing is really hot.
You're good.
Alright, good? Alright, so this is security automation in your continuous integration pipeline. If you like buzzwords, you might like this talk. No. So, who am I? I'm Jimmy Byrd. I work at Binary Defense Systems. I'm the lead developer over there. And we do a lot of development. So, we don't really see too many security talks that are focused on development. And so, this is one of those. And we use some of these practices at work. We don't use all the tools because, we don't use all languages. But when we get through some of it, what happened? Is this thing...
What's your resolution at?
And
are you plugged in?
I'm not plugged in. But I do have it. I'm still moving my mouse around. Okay. So what are we actually talking about? Today we're talking about continuous integration. And continuous integration is this idea that you want to be able to take your code and put it somewhere else in a way and say, I want to compile my code and be able to show that it can actually work on another machine. And so Martin Fowler has a pretty good description of continuous integration. This thing really does not like my...
30-second timeout set, probably?
Oh, no, this cable actually isn't locked together. That makes more sense. So, yeah, basically that's great. So each integration is basically you want to verify that your code can actually work in a way that so other teammates can say, hey, I checked in this code, it didn't break. And it prevents this work on my machine. I mean, how many developers is like, this works on my machine, closing that bug? No, it doesn't. And I can prove it. And so we're trying to avoid this kind of thing. Because also merging code ends up being like this. It sucks, it's tedious, it's hard, and you end up making a lot of mistakes. And so you want to actually have a place where you can fix your problems and show that it's actually, verify that it's actually fixing the problems. And so the general gist of a continuous integration is you want to push up some code. If you're using a statically compiled language or statically typed language, you want to compile it. Run some tests against it. A lot of frameworks use automated test frameworks. If you're using Ruby, you're using probably like RSpec or Cucumber or some of the frameworks like that. Or if you're using .NET, you're probably using NUnit or XUnit. And then you kind of want to just get a report. And so you end up with something that kind of looks like this. It's just, hey, we went out, grabbed a whole bunch of Node packages because Node takes freaking forever. And go ahead and compile those into a little list. Then run some reports on like scanning code, seeing if there's any vulnerabilities in our code. And so some of the TI or CI tools that you'll end up using is probably something like TeamCity, Jenkins, GitLab, Travis, or AppVeyor. And these are all just kind of the same thing, different skins, different companies. It's all pretty much the same. Because in general, when we get to software testing, it's not easy. It's not. We've kind of we're struggling with this in the development world for a long time. And we're trying to get better at it every day, but we're still struggling. And we can write normal tests, and this is something we've kind of been doing for a little bit. Like, there's this testing hierarchy. Basically, what you want to be able to do is write automated tests to say, prove that you're valid, or prove that your code is actually doing what it should. And in this talk, probably prove that it shouldn't be doing other things. And so some of them are pretty basic. You have like unit tests, you have functional tests, acceptance tests. These are kind of more like UI-driven kind of tests. And so it kind of goes up the scaling. And so the problem is, like, I don't understand why we're not running security-based tests, right? It may not be a functional feature, but it's definitely something we need to do. And it's not something we're doing at all. I do love this little GIF. Like, look, I built this cage. He can't escape. This is also, don't write your own crypto. Because this is kind of the same thing. You're just like, why are you writing your own crypto? I wrote my own crypto. Nope, I'm out. Because developers, we like to do weird things. I don't know why we want to do something like this. Why would we commit the password to the database in source control on GitHub? You should actually take a look at that one time. Do a quick Google search for like site GitHub and do connection string and just look how many passwords are out there, or just look for hard-coded passwords in GitHub. It's crazy. Developers do this stuff all the time. Or we end up having, stored in plain text passwords in our code. How many, who just got breached again? Yahoo? Like this week? It happens every week now, right? There's a new password breach. People are using terrible methods of storing their passwords. Why aren't we writing tests saying, hey, I can prove that we're not storing our passwords in a terrible way? Additionally, SQL injection is still there. Why? This thing should have been solved a decade ago. We're still having this issue. How are people getting their passwords taken away? Probably SQL injection in most cases. And so we can write tests to kind of do this. So why aren't we writing both these tests? And, it's something we need to start doing as an industry. And so this slide right here is about the rugged manifesto. It's basically some people have already started down this path. We need to write code that is rigid. It's not something that's going to be it can't be easily attacked, and I can prove it and I can validate it. And so really the one I want to read off this slide here is I recognize my code can be attacked by talented and persistent adversaries who threaten our physical, economic, and national security. Because it's happening. And we see it every day. News is showing us. So we need to be able to approach this problem that we're having and start using tools that help us fix these issues. And so there's an OWASP project called WASP Glue. It recently just changed its name from Pipeline. And so some of the resources that I'm going to have later in the slides is going to be about Pipeline. And so they just changed their name last week. So they have some of the stuff, some of the documentation's updated and whatnot. But this is a tool set that allows you to glue a bunch of different security tools that help you automate testing your code in a secure manner and give you a good report out at the end. And so, the recently renamed it. And so these are some of the maintainers, Matt Conda, Matt Tarasu, and Aaron Weaver. They're all really good people, and they have some other talks that I'm going to recommend at the end. So it's 4 simple concepts, really. You have this idea of a mounter, a task, a filter, and a report. And so the idea of a mounter is just how do you get this into this pipeline or glue. Now, it's kind of weird. I actually liked the name pipeline before. But it's, hey, I want to be able to take a Docker image. I want to look on the file system. I want to give it a GitHub repo. And you can write all these kind of things. We'll show that at the end. And so there's something called tasks. And tasks is the meat of this. This is where it takes a bunch of these tools that you can use to scan your code. You can verify that it actually doesn't have any SQL injection vulnerabilities or other kind of tools like this. And just puts them in one nice package. And so as you can see, there's a lot of Ruby and JavaScript, mainly because this project's written in Ruby and there's a lot of JavaScript that's out in the world and it's really easy for those kind of things to be scanners. But there are some Java ones they've included and some .NET ones. They try to shy away from being all proprietary stuff because they don't want to have to pay for it. But, if we're doing all kinds of static analysis tools or whatnot, someone's going to have to pay for a few of the tools to actually get it in here. So, also, filters. Basically, filters are a way of just saying, all right, I've seen this vulnerability before, or it's a false positive. I know it is. Don't show me again. And then what you can actually do is take this out and get into a report. And so you can get in CSV, JSON, or just a text file. And then you can also import into something like Jira or whatever task management tools that you're actually using to track your bugs. And so what you'll end up having to do to get started, you can either do 2 things. You can use Ruby to install a gem, or you can use Docker and just pull it down, and then you can just run inside a Docker instance. And that's what I'm going to show you today. I'm going to show you just how to do it with Docker. So if we come over here, I already kind of opened it up in Docker. So we can see, if I can type, you can see that we have a whole bunch of stuff in this. And this is a lot. There's a lot you can do with this tool, unfortunately. There's so many flags and configurations you can set. And I'm kind of just going to go down here's the happy path, here's to get the best bang for your buck. So here's the hello world example. And so what we're going to do here is we're going to run glue, and we're going to pass it the command -t, and we're also going to give it ESLint and require.js. What this is going to do is take that GitHub repo node goat, and if you're not familiar with any of the goat projects on OWASP, they're set up vulnerable projects so you can actually learn how to secure your code. So what we're going to do is we're just going to pull this down and run these two tools. And so it's take a little bit of time, so I'll just talk about the two tools. So ESLint is really just a linting tool. It basically just allows you to say, hey, you're writing really bad JavaScript. Don't do this. Retire.js is actually something that looks at your node package dependencies and figures out if there's any vulnerabilities and says, hey, we know this has a known CVE. You should probably update. And then you can kind of, determine like is it severe or not kind of thing. But at least you get the actual value out of that. So, see, it's giving us some findings. We can look right here. So these are I just put them out in text, like default is text, but we could give it a CSV. So basically what's happening here is just saying, hey, these kind of things that you're doing in your project are kind of unsafe. If you look, specifically, that's looking like it's not all the code because it's going to jQuery, so jQuery actually has some problems. Interesting. But linters are not really like super reliable. They're just kind of like, hey, you're probably having a bad coding practice. You probably don't want to do it. But it's kind of more of a coding style in some respects. But it does actually look and say, hey, why do you have something called password in your hard coding a value? Shouldn't be doing that. So it does give you some of those kind of benefits as well. So here's another example of if like retire came back and said, hey, here's a whole bunch of code that's got a problem. One of your dependencies, uglify.js, it's one of your minifiers, has a vulnerability in it. You should probably think about updating. And so this gives you a kind of nice report. And so what you can do with these kind of reports, create a bug report, give yourself, give your developers or have your development team fix this issue. And now you can actually go ahead and say, hey, now I want to get rid of this vulnerability and I know that I'm not going to have this issue. And so one thing I do want to really touch on before getting near the end here is just tasks. There's two different kind of like categorizations of tasks. And you can either use the tool specifically or you can use something called labels. And so tasks are really just like the tools that you're going to be using. And so if you want to look at all the different tasks and tools, we can actually pull up the code. And so there's a giant list of tasks right here. And so you can see all the code bases. It's under lib, glue, and then there's the four things I talked about, the mounters, the reporters, the filters, and the tasks. And this is where you can actually get the giant lists of all the tasks that it supports. And this changes frequently, so some of these things may not be here anymore, or they may be new things. So because they're changing the code. So what you can look is actually say, hey, what is this tool? And you can actually give the tool a name. And you can also give it a label, which is kind of like, well, this is JavaScript, and it's also code. And so what you can end up doing is going ahead and instead of running like a tools, I could actually go ahead and run a label. So you know what? I want to run everything that's related to JavaScript on this. And it'll go and run all the different tools it has for JavaScript. Now, this is going to take way too long, and I'm not going to be able to show all the results. So what you can end up doing is looking at all the different tools, and they kind of don't have a good list of this yet. The documentation is getting better and better every day, but they don't have a good list. But you can kind of just go look at all the tasks and tools and figure out which ones do I need to run. Like, am I running a Ruby code base? Let's run the Ruby tools. If I just run code and run everything, which you probably don't want to do, you could go ahead and run code. And if you see something like this, if you're using like Ruby on Rails, you can use like Brakeman, which is a great tool, and I definitely recommend you should be using it. You can use like specifically to a framework, which is Rails for Ruby. And so basically the really important piece here is you would kind of want to just say, hey, this is the name of a product. So it's like, I want to use retire.js. It's all one word. Labels, it's really just, hey, is it JavaScript? Is it .NET? Is it Java? Is it Python? Those kind of things. And so here's a list of all the tools that recently pulled out. And so this is just basically, hey, run this tool against my software. And so what's kind of cool too is when you create your like Debian packages or your MSIs, you can go ahead and run like AV on it, like clam AV. And so if someone somehow put like a backdoor in your code and packaged with another tool that was malicious, you might actually be able to see that, hey, now we have a virus or malware in our code base, which would not be bad, or would be good to know. Because, the attack can come at any time. If you were in the DevOps talk yesterday, there's so many things that could happen in that entire chain. It could be in the code. It could be during compile time. Someone could change out the linking of dependencies. It could be during package time where you're trying to package it up and send it somewhere. So there's different tools for different situations. Another one is also like using OWASP's app. If you're not familiar with OWASP's app, it's a really good tool for taking web requests and replaying them. And so you can end up saying, hey, I want to try a SQL injection attack. I want to try a cross-save scripting attack. It's really good for replaying that, and you can actually get a report out of that as well. Kind of already ran through the tools. And so here's some of the labels, and some of it's basically, hey, I want to look at file integrity monitoring, or I want to use code or Ruby or this framework or JavaScript. So it's all just a giant list. And so you can also build some of your own tools. So if you're using like a statically or code analysis tool or some type of tool that's not in that list, you can go ahead and build your own tool. So what they do offer is, if you look at any of the tasks in here, there is a base one. I don't know if it's actually a test. Yeah. So they kind of like a base one. So all you need to really do is implement a few methods, change a few names, and you have yourself a way of interacting with that tool that you're probably using in-house. And so you can do that for anything. So if, for some reason the file system or Git is not enough and you're using like SVN or FTP or whatever, you can go ahead and write that tool. And if you can go ahead and write like other outputs as well, if you have, if you want to contact your, like GitHub, if you're trying to upload your results to GitHub specifically instead of like Jira, because they just support Jira out of the box. And so one thing I will test the group here, if you want to, you should write a task for Vigil. And this is a very fun language, just to give you a heads up. So this language is Pythonic in its essence, but what it ends up doing is if you create an invalid code operation, it will delete the offending line. And you're like, okay, well, that's kind of weird. It just deletes my code. Right. And it will do that over and over until the entire code base is gone. So don't make a mistake or your entire code base will be deleted. So go ahead and make a task for that. I'm going to challenge you to do that. And the first time you run your code, you're going to get a giant list. If you're a penetration tester, you've ever gotten a penetration test report, it's kind of the same thing. You're just going to get a giant list, and you're going to have to go through what's the highs, what's the severes, what's mediums, what's lows. And you can also go ahead and use some of those filters to say, this is false positives, or this is stuff we don't really care about because it actually couldn't be affected. But knowing's half the battle. So, we want to get to that point where we're saying, yeah. So we want to get to the point where we're saying we actually know that we have a vulnerability. Because if you don't know, that's even worse, right? You actually want to at least know. And then you can actually take care of it and take the steps to get that solved. And so here's some of the other resources. I'll go back to the first slide. That's where you can actually find these slides. And so these are some more talks on it. Here's the OWASP website about it as well, so you can actually get more information about it here. Go to the GitHub page. They have pretty good documentation on it as well. And so they have pretty good how to get installed and how to get this all started. And then there's a few more talks, one from the creator and one from someone else on the OWASP project, and they kind of just talk about the same, similar kind of things I'm talking about here today. So just go back to the front. And basically that's all I got for you guys. So, you got any questions? No one. So, over your head, too much?
Over my head.
Over your head. All right. All right. Well, thank you very much. Yep.